Hello, everybody. Today we're talking about multiplying a fraction or mixed number by a whole number, and we're on lesson 8.4, page 343. So, the unlock the problem for today. Christina is planning a dance routine. At the end of each measure of music, she'll make a 1 1/4 turn. How many turns will she make after the first 3 measures of music? Okay, so what do we need to find? We need to find how many turns she will make after the first 3 measures of music. At the end, she'll make 1 1/4 turn each time. Will she make more or less than 1 1/4 turns in 3 measures of music? Well, we know that 3 times 1 is 3. 1 1/4 means it's greater than 3, greater than 1, right? Okay, so she has to have more than 3. It'll be more than 1 1/4 then. She has to make at least 3 turns. Okay, so more. We're going to use multiplication to solve this problem. Okay. All right, so let's look at some examples. So we can write and solve an equation. So 3 times 1 1/4, and they want us to multiply the 3 sets, by 1 1/4, but write 1 1/4 as a fraction first. So 1 1/4. Well, we know that we can rename the 1 whole as 4/4. So it's going to be 1 plus 1/4. So 4/4 plus 1/4 equals 5/4. All right, so 3 sets of 5/4. 3 times 5 is 15. So 15/4. Okay, now we can write 15/4 as a as a sum of 1/4. Okay, we will talk about a different way to do this because that is a lot of add-ins, right? 15 1/4. Okay, and then you're going to group 4 1/4 because that will be equal to 1 whole. So find groups of 4s. All right, and I see that I have 1, 2, 3 whole, and I have 1, 2, 3/4 left over. So 3 3/4 turns. All right, so that's one way we could do it. We could multiply the whole number by a mixed number, write out all the add-ins, and group them in by whole numbers. What if we multiply 3 times 1/4? Is the product greater than or less than 3? Well, again, 3 times 1 is 3. 1/4 is less than 1. So it has to be less than 3. All right, so it's got to be less than 3. 3 times 1 is 3. 1/4 is less than 1. So we're not multiplying 3 times 1. So 3 times 1/4 must be less than 3. In fact, it's 3/4, right? Okay, explain how you can tell that 3 1/4 is greater than 3 without finding the exact product. Well, 1 1/4 is greater than 1. And if 3 times 1 is 3, then 1 and 1/4 times 3 must be greater than 3, right? 1 and 1/4 is greater than 1. 1 plus 1/4 left over. So if 3 times 1 is 3, then 1 and 1/4 times 3 must be greater than 3. All right, now this next part is very important that we understand and master, because remember on the last page I told you that we could write 15/4 as the sum of 1/4 plus 1/4 so on 15 times. Well, there's an easier way of doing that method of how to turn a fraction into a mixed number. Right, so we are going to talk about that. That's going to be this example here where we're going to divide the fraction. Okay, and there's also an easier method rather than writing out 1/5, 8 sets of 5/5. Okay, that's again takes a long time. So we're going to apply that idea of repeated addition using multiplication. So we're going to write 8 and 1/5 as a fraction. Okay, so how can we do that? Well, we're going to use what's known as the identity property of multiplication, which states that the product of any number and 1 is that number. So if I multiply 8, the whole number, by 1, I haven't changed the value, right? I still get 8. So I'm going to do this, okay? So 8 times 1 plus 1/5. I haven't changed anything, okay? What I'm doing is I'm going to now rename this 1 whole as the fraction. What would be the fraction in this problem? Well, it would be 5/5. Okay, 5/5 is 1, right? So again, I haven't changed the value of the 8 yet. Or actually, I'm not going to change the value of the 8. I'm just going to rename it. Okay, so I took 8 times 1, which remains 8. I renamed the 1 as 5/5 using the fractional part here. All right, now I can multiply 8 times 5/5. 8 times 5 is 40/5. What's 40 divided by 5? 8. Okay, so plus the leftover 1/5. 40 plus 1, 41/5. Okay. Write 32/5 as a mixed number. So if we came up with a problem like this, typically we would turn it back into a mixed number. Here, in this case, it wouldn't make any sense because that just puts us back where we started, okay? So we have to just pay attention to the question and what they're asking us to do. All right, write 32/5 as a mixed number. So we need to find how many groups of 5/5 are in 32/5. And we can do that by dividing. A fraction is a division problem. The numerator is the dividend. The 5, or the denominator, is the divisor. So the quotient of our division problem will be the whole number. So how many 5s can I take? I can't share 5. I'm sorry. I can't share 3 10s into 5 groups evenly. So I'm going to rename the 3 10s as 31s. So 32 ones I can share with 5 groups. I can share that 6 times because 5 times 6 is 30. And that's going to leave me a remainder of 2. So the remainder will become the numerator of the mixed number. So the quotient is the whole number, the remainder is the numerator, and the divisor is the denominator. So how many 5/5 are in 32/5? 6, with 2/5 left over. All right, so let's keep practicing. Write the product as a mixed number. 5 times 2 and 2/3. So the first thing we need to do is change the 2 and 2/3 to a fraction. Okay, so 2 and 2/3 equals 2 times 1 plus 2/3. 3/3 can rename the 1. So 2 times 3/3 is 6/3 plus 2/3 gives us a sum of 8/3. So renaming the fraction 2 and 2/3 as a fraction is 8/3. 5 times 8 is 40/3. Okay, now it says, so we found the product of 5 and 2/3. 2 and 2/3 is 40/3. But then it says write the product as a mixed number. So now we need to divide 40 divided by 3. Can I share 4 tens with 3 groups? Yes. We can put 1 10 in each group, leaving us with 1 10. I can't share the 1 10 evenly into 3 groups. So I'm going to rename that as 10 ones and bring down, I don't have any other ones to add to it. So how many ones? 3 ones. 3 times 3 is 9 with a remainder of 1. So 13, remainder 1. 13 is the whole number. 1 is the numerator over the divisor 3. 13 and 1/3. Explain why your solution to 5 times 2 and 2/3 equals 13 is reasonable. Well, so I know my answer has to be greater than 10. So 13 and 1/3. So 13 and 1/3 is reasonable. All right, sense or nonsense. To find 5 times 2 and 2/3, Dylan says he can find 5 times 2 plus 5 times 2/3. Does this make sense? It does make sense. Yes. You can think of 2 and 2/3 as 2 plus 2/3. So you could use the distributive property. All right. So since we can think of 2/3 as 2 plus 2/3, I can apply this distributive property and rewrite 5 times 2 and 2/3 as 5 times 2 plus 5 times 2/3. So we're breaking up the 2 and 2/3 into 2 smaller parts and multiplying by 5. Multiplying both parts by 5. All right. Number 1, 2 times 3 and 2/3. So we need to change 3 2/3 into a fraction. So 3 2/3 is the same as saying 3 times 1 plus 2/3. How can I rename the 1? I'm going to rename it as 3/3. 3 times 3/3 is 9/3 plus 2/3, so 11/3. So 3 2/3 is 11/3. 2 times 11 is 22/3. We're going to rewrite that now as a mixed number. 22 divided by 3. I can't share 2 tens with 3 groups, so I'm going to rename that as 21s plus the 2 ones. 22 ones, so 7. 7 remainder 1. So 7 is the whole number, 1 is the numerator, and 3 is the denominator. All right, write the product as a mixed number. 6 times 2/5 equals 6 times 1 plus 2/5. Oh, no, 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 no. This is telling me that we have 6 sets of 2/5. I don't have 6 2/5. I have 6 sets of 2/5. Let me explain. These two things are not the same. This means 6 plus 2/5. So not 6 times 2/5. All right, so 6 times 2/5. 6 times 2, 12 fifths. Okay, so now 12 divided by 5. How many 5s can I take from 12? 2, with a remainder of 2. So 2 is the whole number. 2 is the numerator. The remainder 2 is the numerator. And the divisor 5 is the denominator. So 2 2/5. 3 times 2 3/4. So let's change the 2 3/4 into a mixed number first. Okay, so to change 2 3/4 to a mixed number, we're going to be multiplying using the identity property. We're going to rename the 1 of 2 times 1 as 4/4. 2 times 4 is 8/4 plus 3/4 gives us 11/4. So 3 times 11/4 gives us 33/4. How do we change 33/4 into a mixed number? We're going to divide 33 by 4. How many 4s can I take from 33? 8. 8 times 4 is 32 with a remainder of 1. So 33/4 is the same as saying 8 and 1/4. 2 times 1 and 5/6. So we're going to have 2 times, we're going to rename, well, 1 times 1 plus 5/6. Okay, so we're going to change this 1 whole to 6/6. 6/6 plus 5/6 equals 11/6. So 2 times 11 is 22/6. I'm sorry, 2 times 11/6 is 22/6. We can divide to turn that back into a mixed number. How many sixes can you take from 22? 6, 12, 18. So 3 with a remainder of 4. 3 remainder 4. So our answer will be 3 and 4/6, which is also the same as 3 and 2/3. All right. Number 5. Write the product as a mixed number. We have 4 sets of 5/8. So 4 times 5 is 20/8. 20 divide by 8 to turn it into a mixed number. I can take 2/8 from 20 with a remainder of 4. So the whole number is the quotient. The remainder is the numerator, and the divisor 8 is the denominator. 6 sets of 5/12. 6 times 5 is 30/12. Turn it into a mixed number. 30 divided by 12. 12 times 2 is 24. So 2 remainder 6. So the mixed number is 2 and 6/12. 3 sets of 2.5. So first we're going to change 2.5 into a fraction. Turn 2.5 into a fraction. Okay, so we've been doing 2 times 1 plus 1/2. Rename the 1 as 2/2. Okay, so that's 5/2. Now, when we change the 1, or rename the 1 as 2/2 and multiply 2/2 by the 2, what we're saying is in every whole number, there are 2/2. Okay, so we can do this. 2 times 2, because we know that there are 2 whole parts. Sorry, 2 2/2 in every whole. So 2 times 2 would give me 4 parts plus what's left over, 5. So it's the same method. It's just you're eliminating this step here. Okay, you're eliminating the 2/2 by saying, okay, well, I know in every whole number there's got to be two complete parts. So 2 times 2 is 4 pieces plus 1 part that's left over. So 5/2. And then you can multiply 15. 3 times 5/2, which would be 15/2. Turn 15/2 into a mixed number by dividing. How many 2's can you take from 15? 7 with a remainder of 1. So 7 and 1/2. So number 8. 2 times 2 and 2/3. So I know every whole number in this problem has 3/3 parts. So 3 times 2 is 6 parts. 3 times 2 is 6, plus the 2 left over gives me 8/3. 2 times 8, 16/3. 16 divided by 3 to make it into a mixed number. 3 times 5 is 15 with a remainder of 1. So 16/3 is the same as 5 and 1/3. Number 9. 5 sets of 1 and 2/4. So we know in every whole number here, there's going to be 4/4. So 4 times 1 is 4, plus the leftover 2, 6/4. So we have 5 sets of 6/4. 5 times 6 is 30/4. Take 30 and divide by 4. How many sets of 4 can you take from 30? Well, the closest I can get is 4 times 7, because that's 28. So 4 times 7, 28. Subtract, we get 2. So 7, remainder 2. So as a mixed number, it would be 7, 2/4. 7 and 2/4. The remainder is the numerator. The divisor is the denominator. 7 and 2/4. Number 10. 4 times 2 and 2/5. So we need to change 2 and 2/5 into a fraction. So I know that every whole number, every one of these two wholes has 5/5 parts. So 5 times 2 is 10, plus 2 is 12. Okay? 5 times 2 is 10. 10 plus 2 is 12. So we have 12 parts. We have 12 1/5 parts. All right, times 4 sets of them. So 4 times 12. 4 times 2 is 8. 4 times 1 is 4. So 48/5. We need to now change the 48/5 into a mixed number. 48 divided by 5. 9 times 5 is the closest I can get to 48, with a remainder of 3. So 9 remainder 3. It would be 9 and 3/5. All right, 2 and 1/3 times something is 9 and 1/3. Well, what's going to be the easiest way to do this? Well, how many 1/3s do I have here? I know that 9 whole numbers is 3/3. So that's going to be 27 plus 1. That's 28/3. This 2 and 1/3, every whole number has 3 parts. So 6 plus 1, that's 7/3. So 7/3 times what would give me 28/3? 4. 4 times 7 is 28. 3 times 2 and 2 something is 7 and 2/4. All right, well, every one of these whole numbers has 4 parts. So 4 times 7 is 28, plus 2 is 30/4. Well, since the denominator here is 4, that denominator has to be 4. Okay. Remember, we don't change the size of the parts. We just change the number of pieces of the parts in this type of problem. All right. So something and 3/8 equals 4 and 1/8. Well, since this is 4, I know that this number must be bigger than, it must be at least 1. It can't be 2 because 3 times 2 is 6. So, and we have 4. So this has to be a 1. And we can confirm that 8 times 1 is 8 plus 3 more is 11/8 times 3 will give us 33/8. 4 whole numbers would have 8 parts in it in this problem. So 32 plus 1, 33/8. So that is correct. How can we write 7/3 two different ways as a mixed number? Well, could write 7/3 as the sum of 1/3 plus 1/3 plus 1/3 plus 1/3. So we can write it as the sum of 1/3 plus 1/3 plus 1/3 plus 1, so on, 7 times. And then group or combine the whole numbers by grouping 3 1/3 parts. Or you can divide 7 by 3 to get 2 with a remainder of 1. Quotient 2 is the whole number. The remainder 1 is the numerator of the fraction. And 3 is the denominator. Okay, so 2 ways. We can divide 7 by 3 to get 2 with a remainder of 1. The quotient 2 would be the whole number. The remainder 1 is the numerator of the fraction, and 3 is the denominator. Or we could have listed 1/3 7 times, grouped them by groups of 3/3 to get 2 and 1/3. So those are the 2 ways. All right, 15. Otis plans to make 3 batches of sidewalk chalk. How much plaster of Paris does he need? 3 batches. So every batch needs 1.5 cups of plaster of Paris. So if we were using fraction strips, I would say you'd need 3 sets like that, right? And every batch needs 1.5 cups of plaster of Paris. So All right, so those are our 3 sets of 1.5. Okay. So we know every one whole piece has 2 parts, and we have 3 sets of them. So 3, 6, 2, 4, 6, 8, 7, 8, 9 halves. So 3 times 1.5 is the same as saying 3 times 3 halves. 2 times 1 is 2, plus 1 is 3. All right, so we get 9 halves cups. So how much plaster of Paris? 9 halves cups, but let's write that as a mixed number. So 9 divided by 2. How many 2's can you take from 9? 4. So 4 remainder 1, so it'd be 4 1/2 cups. What's the question? The answer is 32 thirds. Well, the only number here that has thirds is the powdered paint. So if we have 2 2/3 tablespoons of powdered paint, that's 3 times 2 is 6. So every hole has 3/3. So that gives us 6. 2 times 3 is 6. Plus 2 more is 8. So 2 2/3 is the same as 8. 8/3 times what is 32 thirds? 4. 8 times 4 is 32. So how much how many tablespoons will be needed to make 4? I should indicate what the ingredient is, right? How many tablespoons of powdered paint will be needed to make 4 batches of sidewalk chalk? All right. So the question is, how many tablespoons of powdered paint will be needed to make 4 batches of sidewalk chalk? How did we get there? Well, I looked at the 32 thirds. If we multiply 3/4 by a number of batches, I don't change the size of the parts. So the fourths can't become thirds. 1.5. Again, if I multiply 1.5 by a number of batches, it still remains a half as the denominator. So the only one that's possible is the 2 2/3. Okay. So then we change that to a fraction, and 2 2/3 is the same as saying 8/3, because every whole number is 3/3 parts. 3/3 plus 3/3 plus 2/3 is 8/3. So how many batches would be needed of the powder paint? I can make 4 batches of sidewalk chalk, and that would give me a total of 32 thirds tablespoons. Patty has 2 cups of warm water. Is that enough water to make 4 batches of sidewalk chalk? Explain how you know without finding the exact product. All right, well, we're going to make 4 batches, and it takes 3/4 cup of water. And how do I know if that's going to be enough? 4 times 3/4. Well, how many fourths would be needed to make? How many fourths would be needed to make up the 2 cups of warm water that she has? So the 2 cups of warm water would be 4/4 plus 4/4. Well, that's 8/4. Well, to make 4 batches, she's going to need a lot more than that, right? So, no. Okay. 4. Let's just go back to thinking, what if it was just a half a cup, right? So 4 batches of half a cup. 3/4 is more than that, but I'm just saying, what if she had 4 batches of 1/2? Well, that's 2 right there, right? 3/4 is bigger than 1/2. So she needs more than 2 cups of warm water. 3/4 is greater than 1/2. So if 4 times 1/2 is 2 cups, she will need more than 2 cups if she multiplies 4 times 3/4. Okay? Again, I just used a different fraction, 1/2, because 1/2 is less than 3/4. Because 4 times 1/2, that gives me 2 cups, right? Well, if 4 batches of 1/2 is 2 cups, and she needs 3/4 cup, then she's 2 cups can't be enough. All right, so Rita makes sidewalk chalk 2 days a week. Each of those days, she spends 1/4 hours making the chalk. How much time does she spend making sidewalk chalk in 3 weeks? All right, so 2 days a week, 1/4 hours per day. How much does she make in 3 weeks? All right, so 2 days a week for 3 weeks. So 3 times 2. She's going to make sidewalk chalk 6 days. 6 days times 1 1/4 hours. Change the 1 1/4 to a fraction. Every whole number has 4/4 part. So 4 times 1 is 4, plus 1 left over, 5/4 times 6. So she's going to work for 34th hours. 30 divided by 4. 7 times 4 is 28 with a remainder of 2. So 34th equals 7 2/4 hours, or 7.5 hours. Okay, 2/4 is 1/2, so 7 2/4 hours or 7.5 hours. And 19. Oliver has music lessons Monday, Wednesday, and Friday. Each lesson is 3/4 of an hour. Oliver says he will have lessons for 3.5 hours this week. Without multiplying, explain how you know Oliver is incorrect. Okay, so he has Monday, Wednesday, Friday. Each lesson's 3/4 hour. He says he's going to do 3.5 hours. Okay, so 3/4 is less than 1. And 3 times 1 would be 3 hours. So he is practicing less than an hour a day can't be at 3.5 hours. 3/4 less than 1. If 3 times 1 is 3, there's no way he can be at 3.5 in a 3-day period. It's just not possible. To be at 3.5, he'd have to be doing more than an hour a day. He would need to be practicing more than 1 hour a day. He isn't. All right. So that's it for lesson 8.4. Our next lesson, we'll be doing some problem solving, comparison problems with fractions. So until then, may the numbers always be in your favor.